In how many ways can we choose two different integers between minus 100 and 100 inclusive so that their sum is greater than their product? Well, let's get some insight into this and say that the integers are x and y. So x plus y is the sum, and we're interested in this being greater than xy. And what we can actually do is rearrange this so xy minus x minus y is less than 0, and then factorize. This is going to give us xy, and then to get x, we can put a minus 1 here to get, minus x. To get minus y, we put a minus 1 here. The consequence is that we get a plus 1 as well. We can't avoid that. But we can rearrange it now to x minus 1, y minus 1 is less than 1. Now what I did at this point is to consider just different values of x that are gonna and y that are gonna work. So let's look at x being positive and y being negative. When x is positive, we're going to get a number that's greater. So x minus 1 is going to be greater or equal to 0, and y minus 1 is necessarily going to be less than 0. So this is going to work. Notice I don't need to do it the other way around, actually. I don't need to do y positive and x negative because I'll just then double up my solutions. So we can say without loss of generality, we can consider the situation. And there are 100 positive numbers from 1 to 100. And there's 100 negative numbers from minus 1 to minus 100. So we're going to get 10,000 pairings this way. Okay, let's look at some other situations. So one positive and one negative. Right, what about when they're both positive? The only way this can ever work is if x is equal to 1 and then y is positive. Again, without loss of generality, we could obviously consider it the other way around. So now we've got a positive and a positive, but it's only going to work when x is 1, because that will give us 0 here. So x minus 1 equals 0, and y minus 1 will be, remember, y can't equal 1 at the same time, so y minus 1 will be greater than 0. But we're going to get 0 overall, which is less than 1. So then there's x can equal 1, and we're left with 99 possible numbers for y, because remember, we can't use 1 again. So either from 2 to 100, basically. Okay, let's keep this as a running total then. Now, we can't have negative and negative because that will always be greater than 1. The only case I've not considered, and I've left this one deliberately, is one of them being 0. So if x is 0, then x minus 1 is going to be equal to minus 1. I know it's going to be negative, but specifically it's going to be minus 1. Although the negative bit is the most important. So then if I go with y being positive, actually, y minus 1 is then going to be greater or equal to 0. And this will again give us an answer that is less than 1 overall. I haven't double counted or anything. It's really important to not double count because in all the previous cases, I didn't consider x or y being 0. So I'm now just basically looking at all the cases where one of the numbers is 0. And for this, it's going to be 100 numbers because we could have 1 to 100 for y. And that is it. So if we sum these together, the final answer is going to be 10,199. That is the number of combinations. Great. I just want to finally talk about how the answers do it. They use the same kind of approach in creating this inequality, but then they actually decide to look at when the inequality is not true. I did it when it is true. So the total number of cases is 201 times 200, because there's 201 numbers you could pick. Remember, they can't be the same to give 40,200. You have to be aware, if you do it like this, that you've double counted, because you could have, you could go for 1 and 5 or 5 and the 1, and that would give you the same situation. Then the Solutions, they look at when both brackets, they actually focus on the brackets rather than m and n like I did. So if both brackets are positive and at least one of them is not 1, then that would mean it's not true. Or when both brackets are negative and one of them, at least one of them is not -1. So in the first case, there's 99 options for each bracket. That is to have them both positive and not equal to 1. And then the other one has to be different, so that's why it's 99 times 98, which gives this number of cases. Second case, we want them to both be negative and at least one of them not to be -1. So that includes having m minus 1. You can let them equal to 0 here, actually. That's why there's now 101 options, and then you times by 100 for the second one. So if you minus these, that gives 20,398, but then we have to divide by 2 because, like I said, we are double counting, and that will give the same answer of 10,199. Now, I gotta be honest, I think my way is better. I feel like it's pretty comprehensive. I've justified it along the way. So, but yeah, that one is there, obviously, as an alternative.